Okay. Okay, folks, so the recording is in progress, and Deepak, back to you. Sorry for the interruption.
No, quite all right, Ramesh. Yeah, so as I was saying, the key thing about EazyML's machine learning platform is its transparency and the lead it has for that transparent AI/ML over ML majors. What is transparency? Well, it is when your digital colleague explains the reasons behind its recommendations rather than just give a pronouncement, actually explains what went behind it. And obviously that's how humans work. They like to discuss things and understand things. And so that's one of the key reasons that has held AI/ML back in the enterprise. So the pendulum swung way to the right with more and more complex opaque models, deep learning frameworks. And then what everyone realized was that it restricted the use of AI/ML in the enterprise, handicapped it, chained it, because there were very tiny pockets in which they were used. It was not pervasive in the enterprise because your digital colleague did not explain itself. And so it's now swinging in the opposite direction, so much so that people are giving up their complex models at the expense of incurring model bias, to go to simpler models so that they understand. That is how important transparency is, without which it's very difficult for AI/ML to become pervasive in the enterprise and in our life. So sure, there are tiny pockets, computer vision, commercial underwriting, customer experience, but end-to-end process flows ain't gonna happen until the machine starts to explain itself. So everyone's hard at work at this. When you talk to people out there in the industry about what specifically constitutes transparent machine learning, they equate it to explainable AI or interpretable AI. And that is a very narrow, straight-jacketed view, unidimensional view. There's more to it. We'll discuss soon. But explainable AI is when you explain the reasons behind your model's prediction. So not just a prediction, but the reasons must follow. Why is it important? We looked at it. Unless your digital colleague discusses and explains things, it's very difficult to trust. And so the automation and digitization is stillborn. And in many cases, it's required by law. There's no way around it, especially for healthcare and finance, highly regulated sectors. So that's the explainable AI. But there is much more to transparency than just predict and explain. In fact, this is in many ways even more important than explainable AI. If you were to look to Gartner, they call augmented intelligence the future of AI. So why is that? We'll see it in 3 use cases here. Well, what does it do? It does not make any predictions. First, what it does not. Augmented intelligence is not about making predictions. It's about mining insights from data so that you can augment the understanding of humans about the business. So take a lot of data, dump it, and it brings to fore the rules, but patterns buried in there. What works for your business, what doesn't, and why. Here's a very important use case for it. Like we did, more than 95% of the business functions are still rules, policies, and guidelines, whether it's in a paper sheet or coded in an expert system or an Excel spreadsheet or just somewhere in your head. You're just supposed to follow these rules, policies, and guidelines. AI/ML models are few and far between. So what do we do? Can we bridge this gap? If you use augmented intelligence and its insight, you can fine tune your rules, policies, and guidelines so that it starts to perform at par with your AI/ML models. And at the same time, these are very transparent. If a particular rule fired, you know exactly the conditions why it did. Very important use case, one that is going to change the way enterprises look at AI in the very near future. You have certain customers that spend a lot, certain customers that don't. How can we transition those who don't and make them look like those who do? You can try promotions, you can try breaks, you can try behavior based on behavioral patterns. But what are the precise reasons? What is that one or two thing that if you change, it will alleviate the bottleneck, and these customers will start to look more like those who spend a lot. Again, augmented intelligence. So I am going to take this concept of augmented intelligence and really quick apply it to a use case from the financial vertical, and then hand it over to Pranay, who's going to walk you through this for explainable AI for transparent machine. I know Linesh suggested you ask questions at the end, but if you want to ask questions in the context, please feel free to do so. It's quite all right. Any questions, comments? So far, so good? Okay. So here's a workbook, an Excel spreadsheet, and this is the outcome variable, and these are all the predictors, the input variables. What is this about? The bank made a series of loans, and this is real data, anonymized, of course. Made a series of loans. Some of them turned out to be good. They were performing loans that repaid. Some of them not quite so, defaulted. And so the bank was, well, we looked at the financials, we made certain good decisions, and we made certain bad decisions. Can we use alternate additional data to stop making these bad decisions and not extend the loan only to see them default? These are commercial. And so what they said was, say, can you use things like social media, right? Facebook, Twitter, Groupon, Yelp, blah, 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 tweets. What are the customers saying about you? Your online presence, right? Website, content, how rich is your content? Where do you rank on Google and Bing searches, etc. Can you use all that to help us still continue to make loans to the good guys, the ones labeled green and approved, and decline loans to the ones labeled in amber color as the default? Now the question is, so you've got a bunch of underwriters who are saying, how can we use all this apparently powerful social media data and online presence to decline these loans and continue to approve those loans? All right. Well, is there a pattern? There are so many variables, right? And about 600 rows. Maybe the pattern is wherever there is zero footprint on social media, perhaps suggests an uncommitted business owner, and therefore the credit risk, and those should be declined. Well, that's quickly violated. See, the footprint is 2, both Facebook and Twitter, and yet it declined. Well, maybe if there is presence on the social media, but the customers are unhappy, between 0 and -1 is negative sentiment, then still decline. Okay, so I think I got the rule now. I see a pattern. If you have zeros, no presence on social media, decline those. If you do have presence on social media, look for those that have negative sentiments expressed by customer and decline those. Whoops. This has presence on social media and a positive sentiment. That violated that second rule. So you start to see how difficult it gets. You come up with patterns. Without those specific rules, patterns, insights, policies, the underwriters cannot be productive. They want a set of rules to follow. Augmented intelligence to the rescue. I am going to take you through the no-code platform really quick. In 5 minutes, let's sign in with Google. And I'll run through these. It's a very transparent platform. You can hit question mark to see what this step is.
I have a question.
Yes, please.
Can you go back to the Excel sheet? I want to understand the data better before we move on. So the data belongs to a bank.
That's right.
So the bank is making loan to small business.
Yep.
And the loan is approved or declined, but you don't know whether the loan is defaulted, right?
Well, okay. So let me really quick explain this again. Each one of these rows here is a small business, right? This is the first small business, that's the second small business, that's the third small business, and so on and so forth, right? The bank gave loans to each one of these. The loan was approved to each one of these.
Okay.
What happened was that the ones in the green continued to perform. The ones in the yellow or amber defaulted. And therefore, the bank wants to know, can we use additional social media online presence to decline these to begin with, and while keeping those approved?
Right. And just to add to what Deepak said, these were the businesses who were lent money in summer of 2018. And the bank, when evaluated them after 2 years runway in summer of 2020, they found several of them to be defaulting. So now that they have historical data, they wanted to understand, could they have done something? Could they have found those patterns, identified those common characteristics back in summer 2018 itself, so that they would not have approved these who defaulted? So that's why on the historical data, the label is approve versus decline. And the way you would read it, should these loans have been declined or approved? In retrospect.
In retrospect, yes.
That's right.
I see. And these variables like footprint, Facebook, social media presence, and other things, they are like a form, I believe, filled out by the borrower when they apply for the loan?
No, actually, this is alternate data. So traditionally, banks use financial information from the application, maybe assets, the business credit scores, the bank statements, and so on and so forth. That data is complemented with the alternate data, because more and more of late, the banks and lenders, they've been starting to use the alternate data, because despite having those rules, policies, and guidelines in place for so many years, they continue to see the default. So the first challenge is the data complete? So this is the alternate data. The other half of the full system, full data set they should have looked at.
Right. So two questions from that. So in this data set, you don't have the financial statements data. Then when you feed the data to EazyML, shouldn't the financial data also be fed into the machine learning part?
Yes, absolutely. But that is that data is very for privacy and confidentiality reasons. That data is not shared with us. And
Well,
we cannot share it with you.
that is a tremendous disadvantage, right? Because financial statements are very, very important. If you don't have that data, how can you properly learn information from it?
Right. No, you're very right that it is a tremendous disadvantage that it should be one integrated data set. Agreed. So what these bankers were, or I should say commercial underwriters were looking to do was do a quick first pass based on social media and online presence because the financial data is a very expensive process. You do credit pulls, it's a lot of expense that is incurred, right? And it's a process that can stretch out if it requires an interview, for instance, with the applicant, if it raises certain red flags that the underwriter reviewing the case needs to interview the applicant. So that's an exhaustive, expensive process. Can we do a quick first pass right at the top of the funnel to weed out the obvious ones? And that was the intention of the bank. Okay. So what is very important, you made an excellent point. What is very important is a confidence score to say, this is how confident we are that you should weed this out at the top of the funnel. The more confident you can set the threshold and say, if it exceeds this high confidence, then we should weed them out. The rest of them fall down for the regular underwriting process.
The second question, these variables are collected by the bank. How do they collect it?
So there is a solution that Pranay was referring to. It's called the financial risk profiler. See, the financials are lagging indicators of credit risk. If an event were to happen to your business today, by the time it reflects in the financials, it could be a couple of months. Yeah, exactly. Where is the leading indicator of credit risk? Well, the internet. All of our lives are documented on the web, right?
I would disagree. These are not leading. These are past and present too, right? For example, Facebook. They exist on Facebook today. Maybe they don't exist on Facebook next year. So they're also lagging data.
So let's say, I'll tell you why I said leading indicator. Let's say that you are a small business whose biggest customer is Walmart, 70% of your business, right? And end of October, Walmart's decided not to renew your contract.
Okay.
All right. So now you have a real problem on your hands. You have to meet your payrolls, and after 2 months, till 2 months, cash flow and everything exists. It all looks great, but after 2 months, come early next year, all hell's going to break loose. You need the money. You rush to your banker, Linesh, say, "Hey, I need money." Obviously, you're not going to disclosing that your Walmart contract is expiring. Where does Linesh find that out and not get stumped come January 2022 when you default? The way he's going to do it is because someone on Facebook or Glassdoor has commented, I don't know why I got fired. I was telling all along that you should build a relationship with this new procurement manager at Walmart, and it wasn't done, and we lost that major account. Leading indicator. Before that default happens, there is red flags going up.
Okay. These are like procedural question. For example, if they want to know if the company is on Facebook, how do they collect the data? Is this surveyed from the customers? Let's say they give the small business a form to fill out. Are you on Facebook? Or do they go on Facebook to search if that company exists on Facebook?
The latter. So there are solutions, and in this particular case, this data was collected using Datanomer's financial risk profiler, which scours the internet. and collects all the information that you see here are collected automatically.
I see. I see. Can you put the name of the in the chat box, the financial risk?
Okay. Yeah, sure can.
I can do that, Deepak.
Okay. All right. Thanks, Pranav.
Thank you very much. It clarifies a lot of things.
Oh, you're very welcome. All right. So we're back here. So we've got, like the lady just was addressing, you got tons of data, and now you want to know, so what do I do with this data? How do I look for policies and guidelines and patterns that help me make my decision whether at the top of the funnel to remove this applicant or let it through for detailed underwriting? EazyML's augmented intelligence to the rescue. Take all that data, in this case, the Excel spreadsheet, and dump on this platform. And automatically the rules, the policies come bubbling up to the surface. And so we'll see that really quick here. It's a no-code platform driven by Q&As. So the machine recommends what you should be doing at this step. Should you disagree, you are very welcome to change it. But for the purposes of this demonstration, we will trust the machine. Should you want to question it, feel free to do so. Hit the question mark. It's going to explain why it's recommending you this based on what statistical analysis of your data in context. Very transparent platform. So we keep rolling. So we'll upload the data. Can be from any of the clouds, right? All the regular usual suspects are here, but we will just, for purposes of this demo, upload from train. Yeah, we'll do this one. We'll upload. This is the data we just showed. And yeah, I've been playing with it. Anyway, we'll keep rolling. This is what we just saw. Approved, footprint, Facebook, Twitter, Groupon, good. It's got it imported in. ID column, what the heck is it? Why should we identify? Hit the question mark. We'll just trust the machine, keep going, discard, it doesn't. Data types, right? Not ML platforms do that. Categorical, numerical, textual, keep rolling. Min, max, median, mode, great. Outliers, yeah. Oh, what step do you follow? Well, hit a question mark, more details. All right, so you'll know how's the machine removing out. You don't like that, stitch your own pipeline together with the use of APIs. You don't need to follow GUI there. You can use APIs to call EazyML where only it makes sense for those steps. All right, so we keep rolling. Yes, remove the outliers. There wasn't any outlier. This is the process data. Shuffle for KCV. Yes, please. Oh, it's not going to let me proceed now. What is the outcome variable you are trying to predict? Well, the loan decision. And in terms of all these predictors, all right, great. This is the process data. You've got about 700 rows and you've got about 34 columns, all right. We'll skip this in the interest of time. Again, maybe Tableau is your visualization tool. By all means, stitch your own data pipeline. You don't need to go A through Z on EazyML. Use its APIs to call it where it makes sense. All right, so we pre-processed data. Let's go about building models and getting insights now. Yes, let's do that. This is the traditional ML. You make predictions. We are going to do augmented intelligence. No predictions. We just want insights, the policies that underwriters must follow at the top of the funnel to weed out those that should not be considered for further processing. Classification, all right, great. Yeah, we'll just trust you. And feature selection and augmented has found which features are important. Really, it has. What are those? Don't worry, just hit the question mark. Hit more for more data. And there you go. See that? All these features have been identified for you. That profound. So very transparent machine. It tells you everything. All right, good. It's ready to build a model. Let's go ahead and build the models, and voila, the magic happens. So So we were looking at what to decline, right? D for decline. And notice what it says. You decline an applicant at the top of the funnel with a very reasonably high 70% confidence score. Very important. This is very important. This is Pranay's patent pending right here that puts EazyML ahead of AutoML from Google. So decline a candidate or an applicant or a prospective borrower with a very high degree of confidence that meets the following characteristics. This is the magic. Your content score of your website is less than 2.5 out of, it's a 5-star rating, less than 2.5 stars. And your score, rank score on how you appear on Google and Bing is about 3.5 or lower out of 5 stars. Again, means you're not in the top couple of pages of search. And your reviews are less than equal to, from your customers, are less than equal to an abysmal 0.027 out of a normalized 0 to 1, suggesting customer disengagement. It's a lot better to have positive or negative reviews than have no reviews that dry up. That transition is dead. See that? The power of augmented intelligence. Now your underwriter can follow this specific thing as it funnels at the top. And can even, and if they do have those rules, they can fine tune some of those, add new ones, tighten the existing ones, and so on and so forth. So I know would have loved to talk more about the confidence score and how you can configure these things. There are lots of parameters that you can configure, APIs as well, but I'm going to stop share and let Pranay.
Can I ask a question before you move on?
Sure, please do.
Can you go back to the Easy Machine Learning platform? So this is, I'm trying to interpret this. Basically, if I am the bank, I see a company and the content score is lower or equal to 2.51. I would, like you said, I would weed it out. I would decline it at this first screen.
No, these are all the ands, sorry. These are all the and, this and that in that order. So if you will, you can kind of treat it as an if then else statement. If this,
okay,
then if this, then if this.
Okay, so it has to meet 3 conditions.
That's
so if it meets 3 conditions, I would weed it out, no matter how good other conditions are.
Yeah, at the top, with a very, based on your data. So it all is, you're driven by your data. Based on your data, it's very likely that if these are the conditions, you will see a decline.
And
or a default in that.
Can you show that 3 conditions, are these 3 conditions basically from the highest confidence scores, right? They're, I can.
They are from the spreadsheet here, right? So yeah, so for instance, see here. See that? That's the content score.
Yeah, I understand. I understand this part. Can you go to the Easy Machine Learning? So you see the 3rd condition here is normalized review Q1 count is less than equal to this number. And this is a 3rd condition to meet to decline this customer.
That's
but
right.
I don't see it in the background. So where is this term in the background? No, not in the Excel. No, not in Excel. Still in the machine learning. So you see, you have this purple thing, and you have the black thing behind it, right?
Oh,
so,
I see. Oh, this is ... I see what you mean. It got cut off. See that? There is ... Sorry. So you have to just double click on this. See, you just double click on this and it pops up.
Oh, that's how it's done. Okay, I see.
Yeah, because there could be more than 3, there could be 5, and so it's difficult to fit it all in here.
Oh, that's how it's generated.
Yeah, so various rules, right? With decreasing order of confidence.
Right.
You can click any one of the other ones too. And see, for instance, I can double click this guy.
Okay,
Right?
I see.
And so on and so forth. And the machine itself is saying these top 3 I would recommend. After that, it's questionable.
Okay, gotcha. Thank you. That's helpful.
Okay, you're very welcome. You're very welcome. And you can configure those. There are lots of parameters that are configurable. You can verify those scores. You can ask, hey, how do I trust your scores? So there's a way to do that as well. That perhaps we can come on another time, or we can discuss off.
There is a lot of interest in this data set. I'm wondering whether I should stick to this data set or switch to another data set for the Explainable AI presentation.
Switch
Maybe
to
I'll
another
need-
data set.
Okay, all right. No worries. So enough of financial data set. Okay, no worries.
The reason is that I want to see different context to be utilized by easy machine learning instead of just one context.
Okay, absolutely. No worries.
And
So-
remember, Minkao, this one has to do with explainable AI. So we moved away from augmented intelligence now into the other dimension of transparent machine learning called
great.
explainable AI.
That's great.
Right. I hope you can see my desktop, which reads machine learning superhero EazyML.com, right? That's the screen you're looking at. I'm sharing my desktop. Is that true?
Yeah, I can.
Yes,
see that.
we can
Yes,
see it.
we can.
All
see
right.
it.
So this is EazyML.com. You'll find tons of resources in here. There are lots of documentation. There is a lot to learn. There are videos. There are data sets. There is data set repository. Once you sign up, it's very easy to sign up. For you in personal capacity as well as for enterprises, we could create an account for you. And even for you, we can create an account. And by the way, there is a special discount today. Those who are participating and are willing to explore EazyML, there is a special discount code, which I'll put out later in the chat box. With that, you get to use the premium version of EazyML. And what that means is you get several thousands of rows and up to 100 columns in your data set for experimentation. So it's very easy to sign up. Tons of resources in here, right? Guidelines as well as use cases that you.
So Pranay, one thing you can do is just click on the enterprise could you go to the front page, Pranay? Because our theme is transparent machine learning. And just click on transparent ML platform at the top there. Yeah. Highly encourage and request people to go through this, review, and provide us your thoughts and comments. You can see it talks about augmented intelligence, explainable AI, and in terms of presentations and webinars from the past. So it's a good resource since the theme is transparent machine learning. Thanks, Pranay.
Right. Enterprise use cases, you'll get to see those over here, right? EazyML is a no-code AutoML platform. And then as you just saw that, if you don't even have to have data science expertise, no expectations from the users of the platform to have deep data science or machine learning expertise. But let's say if you are an advanced tech user, and then there is something for you. And I'm going to talk about these APIs later in my part of the presentation. But these APIs are used to automate, operationalize your models. If you want to run experiments, several experiments in succession with different kinds of configuration parameters. Maybe you don't want to go through the UI over and over again. You just want to use the APIs and run those experiments in bulk in using scripts. So that's possible too, and I'm going to talk to you about that as well. For now, to show the explainable AI, now which is different from augmented intelligence, explainable AI is about explaining your predictions. So you made a prediction, your model is recommending go ahead and do this. Should you believe in that? You as a curious mind or a practitioner, a subject matter expert wants to know why. Why should I believe that prediction? Please explain. So that's where the explainable AI comes into play. And for that, the data set that I'm going to use is from personalized medicine. Okay. So here is a patient whose recording of his blood pressure over the past 3 to 4 months. That's the data set we are going to look at. The last column in here, which is the outcome column of interest, is the blood pressure reading. High, somewhere from, let's say, 120 to 125 to 150. Normal, which is on the lower end, and okay is somewhat in between. So 3 different classes in here and several features. The sleep patterns, meal patterns, how much exercise have you been doing? Have you been taking any medications? What's the work stress level like? And so on and so forth.
A quick question. The medication morning and evening, are they blood pressure medication or any other medication?
This is any other medication.
So you don't know what the medication is.
Oh, no, sorry. The medication morning and evening are blood pressure medication. The others are actually documented like fish oil and so on and so forth. So those are called dietary supplements.
Right, I see that. So medication is specifically blood pressure. That makes sense.
That's right. That's right.
Right. The dietary supplement is over here, right? The lunch, breakfast, those are the meal patterns. And if you have had any cold or any other symptoms of influenza and all, that's in here as well. So for a period of 3 to 4 months, these readings are taken. And now the question is, in the upcoming days, given these features, some of these features, what do you predict my blood pressure is going to be? So what I'm going to do is take this data set and go through the same sequence that Deepak talked about, but in the context of this particular data set, blood pressure training data, that's what I'm going to use. Again, a preview of the data set. There's no identifier in here, so I'm going to skip that. Auto-determined data types, basic statistics. I'm going to go through the outlier removal. So pre-processing, this is what we are doing is a pre-processing before we build any model. So pre-processing includes outlier removals, imputation, cleansing your data set, making sure that you don't have any holes in data set, all that step. You process the data, specify your outcome variable. In this case, it's systolic pressure. Process data. I'm gonna skip the visualization in the interest of time and jump to model building after pre-processing the data. All of these steps could be done by means of the APIs as well. Now going to model building. So last time we looked at augmented intelligence, that's pattern discovery, auto mining of insights. We are going to focus now on predictive models. Actually, to be honest, most of our deployments, the enterprises, when we reach out to, their use cases fall into one of the 3 buckets. When I say most, more than 90% of their use cases are either about predicting or about forecasting or trending or about mining patterns. So I'm going to focus on building a predictive model. This is traditional AI. So when people say AI, they equate more often than not to predictive modeling. It's classification problem. So here, like Deepak mentioned, it's a Q&A driven platform. It's going to ask you a question, give you some choices, and make a recommended recommendation for you as well. So this is feature engineering. It allows you to derive your own features. Feature selection. If you are a data science practitioner, you are familiar with these steps. And before it builds the model, it gives you a preview of the data set. And does so because, if you have, let's say, a textual data set, it is possible, by the way, to have a textual column in there. In fact, there is a data set. I wanted to give you just a preview of that to show the power of this platform. It allows you to mix and match your date-time columns, categorical columns, numerical columns, along with the chat transcripts. So here, for example, this particular column is textual data in here, right? So in your data set, you could have textual data too. And if you did, then it allows you to derive predictors from the text. Maybe for another session, another meetup, we can talk about the textual analytics. But it allows you to derive sentiments, topics, concepts, glove vectors, word embeddings and all. And you could have those as your features. And if that's the case, then just before model building, you can review what the sentiments are like, what topics are automatically derived, and so on and so forth. And that's why this step, model building stage preview before you actually start building models. When you're building models here, it's exploring the world of all classical models, neural networks, support vector machines, logistic regression, and so on and so forth. And not just exploring all those possibilities, but also optimizing those for hyperparameters. And then it comes back to you with the results. When it comes back to you with the results, you can see that most of those common models are in here, rank ordered by their performance. Since it's a classification problem, the performance is measured in terms of kappa and accuracy. The best model is a back decision tree with information gain followed by KNN. In here, the precision is shown to 2 decimal points, but the top 2 are pretty close. If you go beyond the 2nd decimal point, you will see there is a difference, slight difference. Now, proceeding to beyond the model building stage, it offers you an option to build ensembles. Let's say you wanted to experiment with, let's build an ensemble of top 3, for example. It allows you to build the ensembles too, and those ensembles would show up in the table as well. And it goes a step beyond. It lets you build ensembles on top of ensembles too, if you wanted to go that crazy with your modeling experiments. Now, here is the screen which shows all the important variables which help you with the decision making: work stress level, evening walk, minutes of exercise, and so on and so forth. The top 3 are work stress level, evening walk, and minutes of the aerobic exercise. That plays an important role. Now that you know that these are the globally important variables, it asks you a question. Do you agree that these are truly the important variable, or do you see that there is one variable in there or one predictor in there, maybe which is correlated to the outcome? Maybe there is a bias. So it gives you an opportunity to identify a bias in your data set. And if you believe that there is no bias in the data set, this is how it should be as per your understanding, you just say yes and proceed.
Yeah, this is a very critical thing. Platforms typically do not detect bias. This one, true to its transparent machine learning groups, is very concerned about bias. As they say, a stitch in time saves 9. If you can detect bias at this stage, rather than go through the expensive exercise of building your models, productionizing them, putting them in the cloud, then which is what is done today, and you make your predictions, and then it works well, and sometimes it doesn't, and now you're pulling your hair out. Why are these not working well? You go back to the training data, I need to fix it. Whoa. Versus right here, you will see again, it's going to tell you, I see certain things that—
Yeah, question. How do I answer the question? How do I know if there is a bias or not?
So here's one instance, and Pranay will show you another instance. I'll show you one instance. Let's say you did augmented intelligence on your data for the outcome you are interested in studying, right? And let's say your the insight that is right at the top, which means the one with most confidence, has a confidence score of 0.29. 0.29. That means that the machine, augmented intelligence in this case, isn't confident of the most confident insight for the outcome that you are interested in. Strong indication of that your data set is incomplete.
Can we use an example? I'm not following very well. Can we just use the example? Can you click a previous when we go back to the bias page?
That would require the augmented intelligence flow. Minka, what I'm going to do is, if you can write your email, I will send you a paper that I published.
Okay.
But that would require us to go to augmented intelligence.
I understand, but can you just say very quickly, like training data bias detection, are these predictors influential as per your understanding? If I understand things well, I wouldn't ask the machine learning, right? So I'm a little bit confused. So the machine is asking me if the result of the training is consistent with my understanding.
See, here's the thing. Let's say one of the variables here on whether or not the blood pressure is high was, let's say one of the variables here was I wearing black shoes or brown shoes?
Okay.
Now, if that showed up here, you should be very concerned.
Okay, I see. So it's like a very obvious nonsense kind of thing. Okay, it's
That's right.
Really obvious.
Yes, but downstream, you're going to see another perspective on bias detection that is non-obvious. So watch out for that one.
Okay, thank you.
So when we go to the prediction phase, so predict from your data. So that's the third stage after you have built the model. So I'm going to use, okay, by the way, so here are the choices. It lets you predict from any one of those models it has built in the background for you. Of course, the recommendation is the topmost, but you have a choice to predict from using any one of these models for your curiosity's sake. Another thing I wanted to talk about here is the ability to operationalize your models. You could download the CSV, which is these metrics, this table, but you could export each one of these models individually, and you can run it in your native Python or Anaconda environments, or you could export all of them, or you could export a Docker image, a containerized modeling service, and put it in your environment. If you are happy with the model performance after running several experimentations, several iterations, once you are happy with the performance, you can have the Docker image exported as well. So I'm going to choose the best recommended one, upload the data set, test data set. I have 6 records in here, let's say 6. Well, by the way, this is the stage that Deepak was talking about. The training data bias detection here. It's very different from the previous one. So non-obvious bias detection. So here what it's saying that maybe your test data point, if it is not represented well, then you can't expect the model to perform the rightful prediction. Your training data points, every one of those should have had statistically significant representation in the training. So a very crude example is, if you were trained in mathematics and on your exam paper, you are asked a question in biology, that would not be fair to you. The same way with the model. Model is trained on a data set, understanding, learning from that data set, and now you are throwing the model a curveball, a test data point, which was not represented in your training data, then that's not fair to the model. So that's what this stage helps you detect, right? In this case, I don't have any such scenario. All of my 6 test data points were very well represented in the training data. So I don't have that challenge. But in your data set, you may, and if you do, then it will bring it to the fore here. Running through the predictions, I got the predictions from my model, 6 test data points, all of those features, and the last column has the predictions, okay? Now the question is, Now, this is where we get into the unique differentiator, understanding the predictions. So before you operationalize the model, which means trusting its predictions and taking actions on those. For example, Zillow, model predicting buy. They went on a buying spree. But not everybody wants to blindly believe the models, the black box model, especially if the models happen to be neural network and support vector machine. To understand why it's predicting the way it is, it's very challenging, even for data scientists with wealth of experience to explain. So it's very important to understand the predictions in the ways humans would, subject matter experts would. So here is that feature transparent ML. It allows you to explain, let's say, a specific data point in here. So you click on explain. It's going to run the Explainable AI and come back to you with the explanations. Okay. So understanding the reason for prediction. The model predicted that your blood pressure is going to be high because of the following conditions. Now the conditions is, in this test data point, you said you're not going for evening walk and your work stress level is high. You're not doing any aerobic exercise. And on top of that, you're not sleeping enough. Not just that, it's telling you specific thresholds. You are not doing exercise. You have to do at least about 20 minutes of exercise on daily basis. You have to sleep at night at least 7 hours, to stay. Given your personalized norms, you should be sleeping at least 7 hours a day. So it's giving you reason why it's predicting high. Now, an important measure in here is the confidence score. Just like there was a confidence score for augmented intelligence insights, you must have noticed that there is a confidence score for the explanation. This is not the confidence score. This is not the probability of prediction of this. It's a measure of confidence in these explanations. If the confidence score was something like 37% or 42%, then the machine, based on data that you have, that machine itself is not confident that these reasons are accurate. But if your confidence score is 87, 80 plus, given the data set that you have, machine is reasonably confident here that these are the reasons why the model is predicting blood pressure to be high.
Just notice the power of personalized medicine made possible by actionable insights, actionable explanations. You may be running on your treadmill for 15 minutes and you go back to your cardiologist and say, hey, you told me to be on the treadmill. I am. Between meetings, I make it a point, and yet I see that my systolics are high. What gives? And so the cardiologist says, well, geez, if it didn't help, maybe we should up your dose from 5 to 10 milligrams of amlodipine, right? And go try that. If only you had documented the way your DNA and heart is wired over 3-4 months worth of data. This was about 115 rows. It would tell you that 15 minutes, the way your heart's wired, it takes about 20 minutes for it to start pumping blood to the extremities and good hormones to flow. And if you did that additional 5-7 minutes, you wouldn't need that additional 5 milligrams of amlodipine. Just imagine the power of the transparent machine learning with that confidence score to make it action. Incredible, incredibly powerful.
Right. I know we are at the top of the hour.
Just about to give you a 5-minute.
Yeah, I knew that we are at the top of the hour. I'm just gonna close with the API, description in here. So everything that we did on the UI, it can be done through the APIs too. So you'll find all of that in gory details in here. Every single API to upload the data set, to cleanse, outlier detection, imputation, along with the examples, code examples, parameters, everything is described in gory detail in here. And on top of that, if you are an advanced data scientist, tech user, you wanted to configure, tune the parameters for your experiments, that capability is in here too. In fact, that capability is in here on the UI to advanced settings. All of those configurable parameters are in here. What I wanted to show you was if these API descriptions look intimidating, so there is a quick user guide in that case. You click on quick user guide. There are just about 7 or 8 steps to get you started with EazyML fairly quickly. All this code is also available on GitHub if you wanted to try this out. Authentication, uploading the data set, building predictive models or building augmented intelligence models, making predictions and executing explainable AI. All that is in here. So there are about 10 steps, including the configuration. There are examples in here. In fact, it doesn't take much to do these things using the APIs. And I'm going to show you that very quickly.
You can build your own. Yeah, you can build your own data, stitch your own data pipeline. So for instance, you may have your favorite model, right? Does the job well. I just need to call EazyML's API for the module to Explainable AI so that I get the reasons back for the predictions my favorite model is making. So only call it for explainability. The rest I'm happy. You can stitch your own pipeline.
Right. You could do it on the EazyML models, or you can do it on your own models, which you may have built in your environment, enterprise. All that description is in here too. I just want to show you quickly how to run the APIs. So I have both of those data sets, the blood pressure and the financial one in here. You will find this code, the EazyML client library, as well as the library described in the quick start EazyML API guide. That's in here too, EazyML upload, build, predict. There is a config file. You tell which endpoint to use for, which is going to be the app.easyml.com along with your credentials. If you look at the run.sh, it shows you how to use. So that's the script, that's my username. And here is my API key. Once you have the account, it's very easy to go find your API key. Let me show you. You go to my accounts right in here. You will find all your models, data sets and everything, and you'll find the API key. So that's the API key you use in here. I'm going to do all of those steps that I did on the UI in one shot with this particular command. I'll give a name to my experiment, the training data. What's the outcome? I want to build predictive model, not augmented intelligence model. Here is my test file. Explain these 4 test data points for prediction. So if once I run this, run sh, okay. So it did the authentication, uploaded the training data file. It's perform all those steps like outlier and cleansing, all those steps are there. It's building predictive models. It did the feature selection. Okay, it's building the models. Model building time was that much. The models performance metrics are all in here. You can see that table with performance values of kappa and accuracy. It's uploading the test data file here, the prediction data file, now making predictions. Predictions are ready. You want to see predictions, you can find that in JSON, this JSON output file. Everything from this script is stored in a JSON output file. In the end, the explanations are stored for those data points in the explanations.json, right? So here, for example, explanation along for the record number 2 that we looked at the UI, explanation confidence 87%. What were the variables, local importance, as well as there is individual explanations. Everything is in here. It was done within about a minute or so, everything was completed. for the same data set. And with that, I'll rest my presentation.
Excellent
Any more
presentation.
questions before we move to the next stage? If not, thank you so much for tuning in. And I'm going to post the discount code for EazyML. And I'll also write down my email address there. Please feel free to write an email to me for if you want me to create an account for you, I would be happy to do that as well.
Thank you, Pranay. Thank you, Deepak.
Thank you.
It was a wonderful presentation.
Thank you. Really enjoyed the discussions. Thank you.
Sure. I'm going to stop the recording for this presentation now. So just give me a second. And yes, I saw the question about the recording. Yes, we'll make it available to you at some point. As soon as we get it from the cloud, we'll definitely